This is Module 2, Lesson 2 assignment, Lesson 2 square root of a function. So here we have this function f of x. I made a new graph here. It's just a quadratic here. And we're going to sketch the function y equals root of f of x. So here I just sketched it. Based on the graph here, we have two x-intercepts, one at 4, x equals 4, and one at x equals -2. So those are going to be points on our new graph, and we also have an invariant point here and here at y equals 1. So those are two invariant points, and then the graph is just going to go on forever. Yeah, and so in between 0 and 1, the graph would be above the original, and then past that, it would be below the original. And then question 2, identify the domain and range of y equals f of x and y equals root of f of x, and label the function and its domains and ranges. Then we're going to compare the domains and ranges and explain the reasoning for any changes. So I have this new equation here, x squared minus 35 f of x equals, and then so the root of f of x is equal to this equation. This is the original f of x. I just made a rough sketch, and this would be the square root of that function. So for the domains and range for f of x, we have x is in the real and y is greater than or equal to -35. And for the square root of the graph, we have x is less than or equal to -5.9, and x is also greater than or equal to 5.9, as we can see here, and y is greater than or equal to 0. So the reason for that is that square root function, for square root functions, the range is always greater than 0 because you can't square root negative values. So that also changes domain because no x values for negative y values can exist on the graph. As we can see here, it kind of cuts off all the x values that would have been here because we can only be above the x-axis.